Attention is a technique in deep learning that helps models focus on the most important parts of the input. It was first introduced in 2014 and later became the foundation of the transformer in the 2017 paper Attention is All You Need by a Google research team. That breakthrough paved the way for today's large language models. Why attention? Traditional models like recurrent neural networks, RNNs, and their variants like LSTMs process information sequentially, one word at a time. This is problematic for tasks like language translation, where word order differs between languages. For example, consider the phrase, "I ate the red apple." In English, the color word red comes before the fruit word apple. However, in French, the order is different. J'ai mangé la pomme rouge. Here, the color word rouge comes after the fruit word pomme. Attention solves this by allowing the model to look at all parts of the input at once and decide which parts are most relevant for each part of the output. This is similar to how a human might focus on a specific word in a sentence to understand its meaning. This ability to focus makes attention a core component of modern large language models, LLMs. For this example, attention helps the model correctly associate red with rouge, even though their positions in the sentences are different. How it works. Attention works by assigning a weight to each part of the input, with the most important parts receiving the highest weight. Using our previous example, when it's time to translate the word pomme, which means apple, the model can look back at all the English words in the original sentence and give a score to each one to see how relevant they are. The model looks at all the English words and assigns a relevance score, as shown in here. Notice that apple and red have the highest scores because they are the most important words for translating pomme. These scores are converted into a probability distribution using a mathematical function called softmax. This amplifies the highest scores and reduces the others. The result is the softmax score. The softmax scores are the weights for each part of the input. They tell the model how much attention to pay to each word. Note that the sum of these softmax scores is equal to 1. Then, the model creates a weighted sum of the words. The weighted sum, S, is the result of multiplying each word's vector, or tensor, which represents a word from a tokenizer, by its softmax weight. This means the model gives more weight to the words with the highest attention scores, apple and red. This allows the model to correctly translate "I ate the red apple" as in French words, "J'ai mangé la pomme rouge." In our next video, we will be sharing about the modern attention mechanism used in the LLM tool, Minimind. Thanks for watching. I hope this video was a helpful step in your AI journey. If you found it valuable, feel free to like and subscribe so that you can be notified of any upcoming videos. Thanks for joining me today.